To estimate the height of a building, two students find the angle of elevation from a point down the street from the building to the top of the building is 35 degrees. From a point that is 150 feet closer to the building, the angle of elevation to the top of the building is 51 degrees. Assume that the street is level and estimate the height of the building. This blue rectangle represents the building, so our goal is to find the length of this side here. From the furthest point, the angle of elevation is 35 degrees, so this angle here would be 35 degrees. From a point 150 feet closer, so if this length is 150 feet, then from this point, the angle of elevation is 51 degrees. Notice how we have two overlapping right triangles, where this is the right angle. To keep things organized, let's label some of these points or vertices. Let's label this vertex A. Let's label this vertex B, and this vertex C. Let's find some additional information from our sketch. Notice how these two angles are supplementary because they form a straight angle, and therefore to find the measure of this angle, we can take 180 degrees and subtract 51 degrees, and therefore the measure of this angle here would be 129 degrees. Now looking at this right triangle here, this angle and this angle are complementary, so the measure of this angle in this right triangle would be 90 degrees minus 51 degrees, or 39 degrees. This does not include this small acute angle here. To find the measure of this small acute angle here, if we focus on this obtuse triangle, we know the sum of the interior angles of any triangle is equal to 180 degrees, and therefore 180 minus 35 minus 129 is equal to 16, so the measure of this angle is 16 degrees. We now need to find a strategy to find the length of this side here, which we labeled h. Notice how we don't have enough information to use right triangle trigonometry to find the length of side h, because we don't have the length of any of the sides of this large right triangle or this smaller right triangle here. So let's focus on this obtuse triangle and try to find the length of this side here. If we can find the length of this side, we can then use right triangle trig to find h. So looking at this obtuse triangle, because we have the measure of the three interior angles, and we know the length of this side here, we can use the law of sines to find the length of this side, which we'll call side C. We can say the sine of 16 degrees divided by the length of the opposite side, which we know is 150 feet, must equal the sine of the angle opposite side C, so we'd have sine 129 degrees divided by C. Because we only have one unknown here, we can cross multiply and solve for C. C times sine 16 degrees must equal 150 times sine 129 degrees. So again, C sine 16 degrees must equal 150 times sine 129 degrees. Now to solve for C, we'll divide both sides by sine 16 degrees. This simplifies to C, so we'll have C is approximately equal to this quotient. So now we'll go to the calculator. So we have 150 sine 129 degrees divided by sine 16 degrees, which is approximately 422.9176. This would be feet. Let's go ahead and label this. Remember, our goal here is to find h. So now if we focus on this larger right triangle, this triangle here, because we know the angle of elevation is 35 degrees, and h is the opposite side, and we just found the hypotenuse, we should recognize that we can use the sine function to find the length of h. The sine of 35 degrees must be equal to the ratio of the opposite side to the hypotenuse, which would be h divided by 422.9176. Now technically, because this is rounded, we should use an approximation symbol here. Let's go ahead and solve for h on the next slide. To solve for h, we would multiply both sides by 422.9176. Notice how on the right side this simplifies to h. So we have h would be approximately equal to this product. And now we'll go back to the calculator. Because we have this value already in the calculator, we can just press times. Notice how this brings up the previous answer. Then we'll multiply by sine 35 degrees. Enter. So h is approximately 242.58 feet. So going back to our sketch, again, the height of the building is approximately 242.58 feet. I hope you found this helpful.